Can you solve this unseen TMUA practice question? So this is from the Elite Practice Set 1, and this is the first question. As always, the question is linked in the description. Please attempt the question before you watch this. So we are given that root 2 over root 3 is equal to cos of 10 to the minus 1 of 2x. In other words, cos of arctan 2x. And we know that x is in radians and that x is actually greater than 0. So let's write that here, just so we don't forget that at the end. So we are asked what is the exact value of x plus sine to the minus 1 of 2x. So how do we approach this? When you see something like this with arctan of 2x, what do you think of? You might think of something that we've done in AS Maths. For example, sine x is equal to a half, and then you're asked, like, what is cos x? Or what is tan x? To solve these questions, you normally draw a right angle triangle, and then you label the sides of what you're given. In this case, let's say x is here, and you have the opposite side being 1 and the hypotenuse being 2. Because then you can use Pythagoras to find the third side, hence finding cos x or tan x. So when you see something like this, you immediately think of right angle triangles, right? And in this case, that is going to help us. So what we have there is essentially arctan of 2x is just an angle, right? So let's call that angle theta. So theta is arctan of 2x. So then we know that this forms a right angle triangle. So here's a right angle triangle with this angle theta. We could have called like this angle theta, for example. This is just arbitrary, you can choose any one. As we have arctan of 2x is equal to theta, this must mean the opposite side over the adjacent side must be equal to 2x. So we can arbitrarily choose the opposite to be 2x, let's say, and then the adjacent to be 1. So if you think about it, you have TOA, so you know tan of the angle is equal to opposite over adjacent. Here we have the opposite as 2x and the adjacent as 1. So you get this, which is the same as saying theta is equal to arctan, or tan to the minus 1 of 2x. We want the cos of the angle, right? And we know cos of that angle, cos theta, is equal to adjacent over hypotenuse. We already have adjacent, but we need hypotenuse. So that's why working out the hypotenuse will be useful here. So this is h, and we know by Pythagoras, h squared would be 2x squared plus 1 squared. H is equal square root of that. 2x squared will give you 4x squared, and 1 squared just gives you 1. So we know cos theta is adjacent over hypotenuse. This means that cos theta, which is the same as cos of tan to the minus 1 of 2x, because we set theta as tan to the minus 1 of 2x. Cos theta equals to cos of tan to the minus 1 2x equal to adjacent over hypotenuse. Adjacent is 1, hypotenuse is this thing that we figured out. So that equals to 1 over square root of 4x squared plus 1. And we also know that cos theta, or cos of arctan 2x, is equal to root 2 over root 3. So we then know that this thing we have here is equal to root 2 over root 3. So then how do we solve for x? We simply just squared both sides. Then by cross multiply, so like this, we get ax squared plus 2 is equal to 3. Then ax squared is equal to 1. So we need 2x and x to find this. And I think this is where x is greater than 0 comes in, because when you square root something to find x or 2x, you get two values, right? You get positive x value and negative x value. Divide both sides by 2, we get 4x squared is equal to a half. This means that 2x is equal to 1 over root 2, which is the same as root 2 over 2, by rationalizing the denominator. Then this gives us x is equal to root 2 over 4. Now the question wants x plus sine to the minus 1 of 2x, which is easy to find now because we can just plug those values in. So then we get that is equal to root 2 over 4 plus sine to the minus 1 of root 2 over 2. And from memorizing exact trig values, which is a thing you have to do for TMUA, sine to the minus 1 of root 2 over 2 gives you pi over 4. As we know from the question, x is in radians. So this becomes root 2 over 4 plus pi over 4. And if you look back at the options that the question gave you, they are all in combined fraction form. So we need to combine these. Then we get root 2 plus pi over 4, which is indeed one of the options, option C. Alright, so this is the first method of doing it. Probably most students will do it this way. And it's perhaps the more intuitive method and the approach that is more natural and obvious. There's a second method of doing it, which involves a trick, and a trick that often people don't recognize they can use. Alright, so let's solve it in the second method, which is less intuitive, but it comes with a very nice solution. It's slightly slower than the first method, but it's still a useful method, and I don't think it matters that much in terms of speed. But if you see any question that is similar to this, you should use the first method, as it is often much quicker. So again, in the second method, we set theta as tan to the minus 1 of 2x, which then, instead of drawing a triangle, so if we think about this, we can apply the function to both sides. So being tan, applying tan to both sides actually get rid of the inverse function. So we get tan theta is equal to tan of tan to the minus 1 of 2x. But tan of tan to the minus 1 of anything just becomes anything, because tan to the minus 1 is the inverse function of tan. And we think back to the identities that we need to know for TMUA, which are, we can use the first one here to perform the next step, where we get sine theta over cos theta is equal to 2x. You'll see why we do this in a second. The reason we do this is because we already know the cos theta value, right? Because cos theta is essentially cos of arctan of 2x, as we set theta as arctan of 2x. This means we can actually get a nice expression in terms of x for sine theta. Then we can actually plug in sine theta, represent it in terms of x, and cos theta, which we know from the question is actually root 2 over root 3. So now that we know this, sine theta is equal to 2x cos theta, which is the same as 2x times root 2 over root 3. We already know cos theta, so let's write that down anyways. Then we can plug these into this formula. As we can see, root 2 over root 3 squared is a common factor of both of these terms. So we can take it out just to make things simpler, because we know root 2 over root 3 squared is the same as 2 over 3. So then we get this, because we square 2x, right? And then the other one will just be 1. So then we get 2/3 of 4x squared plus 1 is equal to 1. You get 3 over 2 is equal to 4x squared plus 1. This means 4x squared is equal to a half by subtracting 1 from both sides. Then we arrive to the same point as before, as you can see. So arrive to this point here. Then we just get the same answer. Hopefully this helps you prepare for your TMUA. I'm going to make more videos on answering TMUA practice questions, which reflect the style of TMUA, but teaches you new techniques instead of the techniques that you're already seeing in the past papers. It also incorporates some of the techniques you learned from past papers. But by doing these questions, hopefully you'll get better at problem solving and be able to tackle any TMUA question they throw at you. Please let me know if you have any questions in the comment section below, and also which topic you'd like to see more of, and I'll try and find some unseen questions created by me to help you out.